That was going on 2-7 using a graph to solve quadratics, all right? So right here, guys, we're going to use graphs to factor, all right? So here's our polynomial, our trinomial right here, x squared plus 12x plus 36. If we factor that by hand, guys, I just want to show you two factors that multiply to give me 36. All right, but add to give me 12 is going to be positive 6 and 6. 6 times 6, right? 6 times 6 is 36. 6 plus 6 is 12. So when you factor that, you have x plus 6, x plus 6 equals 0. All right. And when you solve it, you get x equals negative 6, both of those. All right, x equals negative 6. So see how this parabola it bumps right here. This is called a bump. All right. Because the line comes down, it bumps right there and go back. All right, or come down and bump and go back. It bumps at negative 6. All right, and the bump, guys, whenever there's a bump, all right, that's going to be an even degree. All right, even degree. And what I mean by even degree is, see how this is x plus 6, x plus 6? Well, that's x plus 6 squared. All right, so there's two x plus 6's, all right, which equals x minus 6, x minus 6. All right, the multiplicity of negative 6 is 2. All right, so that's a multiplicity of 2. All right, multiplicity is 2. It just means there's two negative 6's. All right, two negative 6's. Oh, I put bump. Good night, bump. All right. Anyway, right here, this quadratic. Notice how it goes through. It slices through this number right here, which is going to be 5, and this one right here, which is negative 2. Now we factor that. I'm just going to show you. Two numbers that multiply to give me negative 10, but add to give me negative 3. It's going to be 5 and negative 2. I'm sorry, negative 5 and 2. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. All right, so you have your factors. And they equal 0. And when you solve it, you get x equals negative 5. Negative 2. And x equals 5. All right. So these are called slices. All right, slice. It just slices through that point once. All right. Whenever it's a slice, that means the multiplicity is 1. All right, multiplicity is 1. And what I mean by that is there's only one negative 2 in the answer. All right, there's only one, or one factor of x plus 2. You know, if you move this back over, it's positive. So there's only one x plus 2. And likewise here, there's the multiplicity of 5 is 1. All right, now this stuff I'm talking about multiplicity, that's going to be in the next unit, but I still just want to kind of introduce it right now. All right, but the main thing is factoring using a graphing calculator. All right, this one right here. All right, first of all, you know, if you factor this, the sum of two squares, you get x plus 2i and x minus 2i. All right. The sum of two squares. Well, see how this doesn't go through the x-axis? So that means the zeros are imaginary. All right, so what you would do is just set this equals 0. Or if you solved it by a radical, right? You could solve it, subtract 4. Right? And then square root both sides, so you get x equals plus or minus 2i. All right, because the square root, you get plus or minus, the square root of 4 is 2, and the square root of this negative is I. All right, so you have two imaginary answers. All right, so anyway, the multiplicity still would be 1, because there's one positive 2i and one negative 2i. Okay. All right, the last thing I want to talk about right here is going to be if a solution of a graph is imaginary or not nice values, you can use other methods we have learned to solve for the values. So for square root, all right, for square root, guys, use the square root method if x squared is the only value. It's the only variable, excuse me. All right, factoring. All right, factoring. Use factoring when it's nice. All right, when it's nice, or pretty factors. All right, pretty factors. Ideal. You know what I'm saying? Like when the trinomial starts with x squared. All right, and the leading coefficient is 1. All right. You just want to factor when the leading coefficient is 1. Completing the square, you can use this when x squared has a coefficient, a leading coefficient of 1. All right, you want to make sure that you make the leading coefficient equal to 1. All right, make sure it equals 1. Use the quadratic formula if it's not nice. All right. And graphing, guys, you can just use graphing to check oneself. Oh, misspelled that. All right, use to check oneself. All right. Now, there's some practice problems right here. State which method, and then show solving the solution. All right, use one of each. All right. So listen, man, you decide which one you want to use. All right. You decide which factoring method you want to use. And yeah, factor these and we'll talk about them. That's it, man, for 2-7. Make sure you check out the test review video, which is coming up on Thursday, September 13th. We'll have a test, okay? All right.